All right. Greetings. We are back with Black Bear News. What's going on, guys? And we are also live on Rockfin. So you can also watch us on Rockfin, ROKFIN .com. Oh, no. And hopefully that switches to free. I don't know. I forgot to... It takes a lot to set all this up. But I forgot to push the button for free on the Rockfin video, so I don't know if you'll be able to see me there. But nonetheless, if you can't see me on Rockfin after the show, I will make it free, and then you can watch me on Rockfin for free after the show is over. But anyways, guys, without any further ado, I wanted to say hello. I have Jim Massa here with me, and thank you all for joining me today for this discussion with Jim Massa around... various topics of climate change, the situation of climate change. So I'm going to get into it. And let me get this on. And I just wanted to welcome Jim Massa. How you doing, Jim?
Thank you. I'm doing well. Thank you for having me here, Kevin.
Yeah, thanks for coming. And I just wanted to start off by asking you a bit about your background in climate science or climate change, or you know how you got into the study of or speaking about climate change?
Well, I came to Alaska over 30 years ago, pursued graduate studies in oceanography, so I'm an oceanographer, and ended up working at a new institution on the campus, University of Alaska Fairbanks, that was devoted to climate change in the Arctic. Became involved with a group of folks looking at sea ice, and there you have it. So,
Right. Okay. Yeah.
So we would go up to Barrow quite often, and the Chuck She Sea was kind of my office. So and, go out there measuring ice thickness, extents, trying to correlate with the satellite data that was available at the time, and a lot of on the ground field work, which when you hold the bears around, you turn off your snow machines, you leave those things running.
Right.
Bears might come into camp.
Yeah, Jim, one second. So your volume is low. I'm getting reports that you're low. So is there a way that you can turn your volume up?
Okay. Let me see if I can plug this.
I kind of assumed that this might be a problem, and it is. People can hear you. You're just low volume, so it's okay. We can catch this earlier in the show.
I'm trying to see if I can switch over to my microphone.
Okay. Yeah, you should be able to in the Zoom audio settings there. Should give you an option for your microphone. Rich Diana says Jim lived it while studying it. Indeed.
That's true. This here. Is that any better?
Is there a volume control on your end on Zoom? I'm wondering. Audio settings.
Yeah, I'm swinging that over. Okay, how's that?
It sounds like you went up a little bit. Guys, can you hear Jim a little better? Rich Diana said worse, but hold on one second. You just fixed it, Jim. So can you speak a little bit into the mic, Jim, and let's see if we can hear you.
Okay, is this any better?
Hold on.
Hey, testing. 1, 2, 3. Testing.
Hold on.
I'm hearing that okay in my headset.
Better. Okay, Irk1 says better, Jim. It's all good. It just takes a little while to get.
Yeah.
because there's a 5 or 7 second, 10-second lag in the video, so it takes a while for people to get. Okay, so you're good. We're good. All right, we got that quickly out of the way. So Jim, yeah, so you were up in Alaska. You were in Barrow. You were measuring the ice thickness.
And use of satellite data. We're also looking at we're constructing heat budgets and looking at surface current flows to kind of get an idea of how the surface currents in the Arctic Ocean were moving around and how that would transport the ice. In fact, the work that the research team I was in, along with the meteorologists were doing, the atmospheric scientists, that led to the discovery of what we now call the Arctic Dipole, which is an oscillatory system in the Arctic that actually determines whether sea ice will stay constrained within the Arctic basin or if the ice gets pushed up the Fram Strait.
Okay.
In certain years. So, and that's in conjunction with the Arctic Oscillation. So it was kind of exciting to find that out and be part of that.
Sure. Can you just for the viewers at home or for people who might not know, can you explain Arctic oscillation just very briefly?
Arctic Oscillation is, and that works in conjunction with the North Atlantic Oscillation, where basically we have changes in the high pressure systems and the low pressure systems, where they're situated, and how that influences the stream, for example, and how it influences temperature, pressure gradients, and all those other parameters, and that can then control whether mid-latitudes are going to be cooler or warmer, have more precipitation, less precipitation, what kind of precipitation, and other weather events, even if it's part of the climate system. So everything on the planet is interconnected. And so the Arctic Oscillation involves that. If I can just kind of shamelessly say this, on my YouTube channel, I actually go into great detail on the Arctic Oscillation, the North Atlantic Oscillation, and other oscillatory systems. I do a deep dive on those systems. So if folks are interested, they can go to my channel and take a look at those videos.
Can you give people your YouTube channel?
It's Science Talk with Jim Massa.
Science Talk with Jim Massa. So some people are hearing you, Jim, and some people are not hearing you. I don't know why that is. Is there any way you can turn it up any more? Or is it? Can you get the mic closer to your face or your mouth?
I can lean right into it like so.
Oh, that's about as far as it goes. Okay, yeah, I don't want to make you do that. Well, some people are hearing you, so I can't really crank Jim Moss's volume, guys. I don't have control of his volume on his end.
I got mine cranked out all the way as well.
Right. Let me see if I can do one thing. Hold on, guys. Are you hearing the volume any better or worse, Jim? Can you just say hello for a second?
Hello, folks.
All right. Lightning Rod says don't crank any volumes. Okay. I don't know. We're gonna have to just do this, Jim, and I can hear you, so it's picking it up on the video. So we're gonna have to go forward. I'm sorry for those who can't hear Jim. Just try and I don't know what. Come back and watch after the video's over. You'll be able to hear Jim. So let's talk about what's going on in the Arctic right now, if we could. Obviously, I was just talking about a tweet from Zach Labe, and let me see if I can pull this up without destroying everything. Well, hopefully not too destroyed. Zach Labe, I think people might be able to see this. Arctic sea ice extent is currently the second lowest on record. About 440,000 square kilometers less than 2010's mean, 980,000 square kilometers less than the 2000s mean. It's, et cetera, right? So it's gone from over 2,000 square kilometers, 2 million, sorry, 2 million square kilometers in the 80s to 1.7 in the 90s, less than a million in the 2000s, and less than 500,000 in the 210s. And where's it now? I don't know. I'm looking at the graph. It's about, is that 90,000 or 900,000? Graph is a little bit strange to me. But anyway, so can you speak on what you're seeing as far as the situation in the Arctic now? I mean, we had a second lowest extent this summer, and it's not, there's some places that aren't refreezing. So if you could just expound on that a little bit and what you're seeing.
Well, yeah, to be quite blunt about it, the Arctic is no longer the Arctic. We're seeing a new, basically, I don't know what term is going to be used to describe it, but with Neo-Arctic or something, but we're seeing a new system emerging. And there's a lot of things going on in the Arctic, a lot of things I've seen in my 30 plus years up here. We have temperature warmer than they used to be. We don't get the 50, 60 below cold snaps of 2-3 weeks like we used to. Temperatures are much more milder in the wintertime. We had the issue with the permafrost dying, and of course all the organic carbon being broken down, releasing CO2, methane into the atmosphere, all the problems associated with that. But in a lot of ways, the loss of Arctic sea ice is really the big game changer in my view, because when you have the sea ice there, and for that matter, land ice, you have a lot of albedo. So there's a lot of heat energy reflected back into space. This bounces off the ice sheets. Now you got open water. Well, now we've also lost multi-year ice. So whatever ice is formed is not as white. So it can be a little more opaque, which means some sun energy can go through that ice. So now you have open water. You have less than 1 year, less than 2 year sea ice. You don't see the 4, 5, 6-year-old sea ice anymore. So you have all that energy now being absorbed by the oceans, which is a reason why the Arctic is warming twice as fast. I'm now seeing estimates saying the Arctic is warming 3 times, even 4 times faster than the rest of the planet. And so, and water has a high specific heat capacity. So it's going to hold that heat, and it cools off very, very slowly. So that is a contributor as to why the ice melts earlier. It forms later in the year. Right. And it's a contributor as to why we're losing the multi-year sea ice. We just have all this heat energy. The heat energy is given off, and that keeps the air temperatures milder. It also leads to more precipitation. And then the other thing is, without the sea ice, the coastlines are not protected. So now you have storms and wave actions just battering the coast, and we have whole chunks of the land falling into the ocean.
Okay, I'm gonna keep that thought. Mike, can you put your this mic part that's on your headphone? Can you put that down? Is that any better? Maybe speak into that.
Okay. Well,
and continue what you're. But continue what you're saying. I'm just gonna see if that. Sorry.
Okay, so so the coastlines are now exposed to battering from waves and storms because the ice is gone.
Right.
But the main thing is that with the loss of the ice, the energy is now being absorbed instead of reflected into space, and that is a major contributor to why the Arctic is warming so much faster. And as I often say, what happens in the Arctic does not stay in the Arctic. it goes worldwide.
Right. And well, so I was reading a bit about your bio, and you said something. Well, you also said to me when we spoke on Twitter that you consider yourself a doomer. And what exactly does that mean? And what you know, I think a lot of people on this channel would consider themselves doomers just because they recognize the reality of where climate change is going. So where do you see climate change going? Why are you a doomer?
Well, I'm not, I mean, people accuse me of being a doomer. I'm basically saying I'm being a realist.
Right.
Because in my view, and there are going to be those that disagree with me, and that's fine. But in my view, looking at the data, looking at what's happening, and I've done videos on this, but I think we have gone past the tipping points. I really do.
Yeah.
There's just so much thermal inertia, thermal energy in the system that even if carbon emissions were to go to zero this moment, which is not likely, and I don't think it ever will, is that things are going to continue warming along with the effects that we've seen. And if you think about it, we did an experiment on this already earlier this year. We had the lockdown. There were very little air traffic. So carbon emissions, at least from the airplane contribution, went down, and it was measurable. It was a noticeable decrease. The
Right.
temperatures continued to climb.
Right. Right. And yeah, I think a lot of people share your thoughts on this, and I feel that more people are moving to the side of doom than away from the side of doom, right? So the idea that it's not as bad as some people are saying, or the idea that we're going to have time to fix this, or the idea that we're going to institute a Green New Deal. And we're going to be able to turn this around in 10 or 20 or 30 years. And I feel like people are hanging their hopes on, they're hanging their hopes on frailer and more fragile, hat stands or coat stands, right? That it's just barely taped to the wall now, and it's just like flopping around, and people are like, well, there's still hope. There's still hope. We're gonna make it, guys. And I don't think, more and more people are moving to the understanding that we're in bad shape, and
We are in bad shape, to be blunt. I've seen so many research papers, excuse me, where they do some modeling, and one of the things that is being put forth was, we used to hear, well, we'll probably get to maybe 3C increase by 2100. Well, that
right,
is now considered to be a low ball. I'm seeing 5 degrees C. I'm seeing 7 to 9 degrees C by 2100.
right,
And basically because the mistake that's been made in the past was assuming a linear increase in temperature increases, melt rates, that sort of stuff. And now we're seeing that things are exponentiating because the positive feedback loops are kicking in.
right, absolutely. And well, so if we're reaching 7 or 9 C or whatever by the end of the century, then what does that mean for the timeline of getting to? We know we don't even have to get that hot for things to be very, very bad, right? I mean, the Paris Agreement guardrail is 2C, and I was just reading an article yesterday, or maybe it was the day before, that said that even if all the countries keep their commitments, we would still reach 2.1C by the middle of the century. And I'd say, obviously that's very conservative, right? So if 2.1C by 2050 is conservative, how quickly are we really going to reach 2C? How quickly are we really going to reach 3C? And I think at 3C, people are pretty much in agreement that it's a bad time for everybody, right?
Humans basically evolved on a planet ppms of CO2 in the atmosphere.
Right.
And we've now crossed over 416, 415, 416, depending on whose measurements you look at. I saw research some time ago from an Australian think tank that basically said things continue as they are, civilization will unravel by 2050.
Right.
And when you think about it, 7 to 9C increase by 2100, that's more than halfway towards the hothouse Earth that was experienced during the Paleocene Eocene thermal maximum, the PETM, where temperatures were about 16C above pre-industrial levels.
Right.
And so a projection of 7 to 9C in basically 80 years, as I always try to stress in everything I do here, the key is the rate of change. And the rate of change that we're seeing is nothing that we have data for pre-industrial.
Right.
It's just so rapid. And that's the alarming aspect of all of this.
Right. Right. I don't think people are prepared for how quickly. I mean, even just looking at what has happened in the last 5 years, as far as extreme weather events and what's happening in the Arctic over the last 5 years, we just, just a day or two ago, it was over freezing in the Arctic. In late November, early December. That's not only unheard of. That's highly, just highly unusual, right? So that's just way out of the norm.
And when you look at, as you just said, over the last 5 years, how rapidly things have changed, that's going past the tipping point.
Right. Right. Absolutely. And so, I don't think people understand what the next 5 or 10 years are going to bring. And
as an example, okay, we're talking about the Arctic sea ice. Well, I'm sure you're familiar with the BOE concept, the Blue Ocean Event.
Yes.
Concept. Well, basically, the models are indicating that somewhere between 2022 and 2024,
yes,
the Arctic Ocean will have absolutely zero ice in it for at least 2-3 months of the year.
Yes.
June, July, August area. Actually, July, August, September.
Right.
No ice anywhere, period. Then there's a BOE +2, +5, +10, which basically states that by the middle of the 2030s, the Arctic Ocean will be ice-free year-round.
Right. Do you think
significant impact and implications?
Do you think we even make it to the mid-30s with ice in the Arctic?
I don't know. I mean, these are I won't call them predictions, but these are projections, estimation. But based on the models and what they're projecting, that's the current information. Now, as they collect more data and adjust the models, it could very well be that we have an ice-free Arctic sooner. Hard to say, but that's the path we're headed towards.
When I look at, when I just look at a graph of the Arctic ice, and I see the trend line, you just look at the median trend line.
Right.
I don't see how we even make it to 2030. Because where the trend line ends is, middle of this decade.
It's very possible. I mean, especially if you look at what happened to Laptev Sea with the East Siberian Sea, the Chukchi, and so on. Chukchi Sea was ice free. That's unheard
right.
of. The Laptev Sea had zero ice. I mean, it's just crazy, and it all goes back to open water, absorbing sun energy, retaining that sun energy, which prevents ice from forming. It has to cool down further and further into the year, so you have less amount of ice for a shorter duration, and it's just going to keep building and building until no ice forms, period. And that's certainly where we're headed. that's just going to be a game changer for the planet.
Yes. I, I shudder to think about what is going to happen to our ability to feed, almost 8 billion people on the planet when, systems start to break down. And, depending on how quickly we heat up and how quickly that starts. I mean, we're already seeing, major crop damages due to extreme weather events. So, you know, at what point do we tip over the edge, if you will, of being able to have a surplus of food and people really starting to feel, a lack of being able to conduct agriculture at scale.
I did a video called "The Too Many People on the Planet," and I've been getting a lot of pushback on that. Basically, it's a simple ecological principle called carrying capacity,
Right.
which is defined as, right, we know what that is.
Yes.
And basically, to be blunt, there are too many people on the planet. Too many people on the planet to sustain. You need land to house people. You need land to create food. You need land to conduct business. And we're rapidly losing that. We're losing good quality land because as you have more and more people, where are you going to house them? So that means you have to take up land that could be used for food production to house people. So now you have less land for food production. And people that criticize and saying, "Oh, the problem is food waste." It's like, no, we're not making enough food. And the food that is being developed, well, first of all, we're seeing what? We're seeing a reduction in the yields of the crops, and the nutritional value of the crops themselves is also declining. So it's kind of a double edge right there.
Yes. Yeah, I'm really enjoying, and I have to, I'm saying this as somebody who is a harsh critic of industrial civilization, but I'm really enjoying the normalcy of industrial civilization at the moment, or what is left of it. Excuse me. And it's just not going to be. A lot of people out there see what's coming and see what is, coming in the near future. And some people seem to be maybe cheering it on, or they can't wait. And I'm like, yeah, it's not going to be very fun, So what I'm not making a judgment necessarily on people's outlooks around this, but personally, I'm enjoying a little bit of normalcy before things get really weird. And I feel like coronavirus is, if people are really disturbed by what's happening around coronavirus or around COVID, this is just, I feel like on some levels good preparation for people to start preparing for some more weirdness.
If I may, here's another thing to be concerned about with the thawing of permafrost from the Arctic, is that we don't know what pathogens are waiting to be released. Pathogens for which we have absolutely zero immunity against.
Exactly. And I actually always, I feel like there's a flip side to that, which is that, there are pathogens in the permafrost. There are pathogens that are kind of waiting in the wings. But as the earth gets warmer and as we degrade the environment more, our immune systems, our ability to fight off these pathogens are also going to decrease, right? So we're, our own systems are going to break down as our system outside of us is breaking down, and that is just going to make us more vulnerable. Because we are in the process of poisoning not just the entire world or globe, but ourselves as well. So we're setting ourselves up for some major hurt. But
Well, going back to the carrying capacity concept again, when too many individuals of a population are present, corrective measures
Right.
to reduce the population. It's basic
Exactly.
knowledge.
Well, and I think I actually we had a little back and forth on Twitter, or maybe we were having a back and forth with somebody who was claiming that the idea of overpopulation was debunked,
Yeah.
or not in play. And you did reply with something extremely logical, uh, and basically along the lines of the idea of carrying capacity, on the idea of there are only so many resources. And I have a graph which I've been showing for the last couple days, and I'm just going to keep it in my computer because it's so pertinent. And that graph is, if everybody lived as we live in the United States, we would need 5 Earths worth of resources, right? We every year we passed the limit of the planet to house the human race, basically. To provide the human race with resources it needs to live. We overshoot that every single year, right? Somewhere in the summer. And it's like we're at 1.7 or 1.8 Earths a year. That's the entire population of the globe. But just the population of the United States alone, the people in the United States, they use 5. If everybody lived like we do in the United States, we would need 5 Earths. And if everybody, it goes on down the line to even in Brazil, they use 1.7 Earths in Brazil. So the only major country that uses less than 1 Earth's worth of resources a year is India. They use 0.7. And there are a lot of people in India, but it is how are they living, right? What kind of wealth do they have? What kind of standard of living do they have? What kind of modern conveniences do they have? China is at something like 2 or 3 Earths a year. I feel like it is about population. It is also about consumption. I think they go hand in hand, right? So.
Oh, yeah. I mean, you can't have exponential / infinite growth on a finite place.
Right.
With finite resources. It's first of all, it's not logical, and it's definitely not sustainable. And a crash / correction it will happen. It can't say it will.
Yeah, and it's when that crash, we're seeing the correction as extreme weather events. We're seeing the correction as droughts, floods, heat waves, wildfires, right? And they're oftentimes happening in places where people are the most vulnerable, or people who didn't necessarily cause all the damage, are right,
Right.
but are feeling the effects.
I mean, think about it. In 2020 alone, there was a major wildfire on every continent except for Antarctica.
Mm-hmm.
We started with the Australian fires. We had fires in South America. We had the West Coast fires. We had fires in Siberia and Africa. There's been major fires on every continent except for Antarctica.
Right.
1 year alone.
Right. And there are fires in the Arctic and the Arctic Circle. There are fires in what used to be permafrost areas. There's they are basically encroaching on every part of the planet. And Australia has just started their summer, so I can only imagine what's going to happen in Australia this year.
Yeah, and don't forget, the permafrost. You mentioned fires in the Arctic, and that's an important point because as the fires burn, you're doing what? You're drying out the ground, and you're heating up the ground. So now the permafrost is going to be thawing ever more so, releasing ever more methane and CO2.
Right.
So that again is part of that positive feedback loop that exacerbates what happens, and this is what we're seeing.
Exactly. And let's talk about that. What do you? So we have a CO2 equivalent of over 500 parts per million, right? So if we take the
I think it's about 564, something like that. I think that's with some recent data that I saw. And that's when you take the methane and you adjusted in terms of CO2 equivalent, yeah, we have, as you said, well over 500. That's not a good thing.
Right. And what does that, what does that mean for? I think I finally got the sound right, guys. But what does that mean for the future of heating, right? So we're talking about even if we stop all emissions now, or if we lower emissions drastically over the next 5 or 10 years, we already have. We're at officially CO2. We're at almost 420. Methane is at three times the baseline. What methane should be, the baseline was something like 700 parts per billion, and now it's at 1900 parts per billion. So it's 2.5 times or something like that. I don't know, I'm just making up math right now, but it's that's got to be alarming. And given the heating, and not to mention nitrous oxide and other gases as well being thrown into the mix. So where do you think that takes us? How quickly do you think it takes us there?
Well, let's I mentioned earlier, some of the research I'm seeing with the modeling is showing a 7 to 9C by 2100. That's where it's leading.
Yeah.
It's leading, and because those models took in the methane, the CO2, they did the CO2 equivalent, and then they projected in now an exponential increase, because that's what we're seeing. That's what the data tells us. And then they make the projection of 7 to 9C by 2100. So that's where it's headed. And quite honestly, planet Earth will carry on for another 5 billion years. Human civilization probably will not.
Right. So I think I'm gonna wrap it up fairly soon, Jim, and I just wanted to ask you a few more questions. We got a little better sound, but I think we've been dogged by some bad sound issues, and so maybe we can do this again, soon, and I'll try and figure out what the sound is. But I can hear you, and I can hear you on my monitor, but but a lot of people are saying that they can't hear you, so that's unfortunate. But what do we have a way out, or do we have a chance? My first question is, do we have a chance of turning the Titanic around?
Oof. I don't know what the answer is to that. I'm not optimistic. To be honest, I'm just not. I see too much thermal inertia in the system. I'm looking at a research paper now that says that basically hypothesizes that even if humans were to go extinct this very instant, there's enough warming in the system that the planet will keep warming for the next 500 to 1,000 years.
Right.
So, again, it's a projection, but this is what I'm starting. This is what I've been seeing, and I'm seeing more of in the research papers. And don't forget, though, a lot of people, quote the IPCC. Well, the IPCC has a history of underestimating what goes on, and a history of kind of ignoring the methane question.
Right.
Which, that's kind of like irresponsible. Not kind of, it is irresponsible.
Yeah. Well, and when you're looking at the product of the amount of just carbon dioxide in the air, the carbon dioxide emissions that we've released, and you don't take into account the methane that is already in the atmosphere and the methane that is soon to be in the atmosphere. The increase in methane. I don't know. Like I feel like maybe we might possibly have a chance to do something about this, but we're not going to be able to do it unless we're in reality about where we're at or what's happening? You know, like do we adapt? Do humans adapt to this? Because there's no way to fix it. So, you know,
It's going to be a new world order, that's for sure. And don't forget, you know, with the sea ice basically disappearing, we're now seeing the methane hydrates, you know, bubbling out of the, you know, for example, the East Siberian Arctic shelf, and on the slope as well. So we've got methane plumes coming out of the ocean. We've got literally the permafrost exploding in Siberia. They'll just get the explosions of methane into the atmosphere. I mean, when you look at the landmass that we're involved with, there is a lot of methane, potential methane in the ground that could be released into the atmosphere, which would bring on very dire situation. And the question is, how much methane is in the ground and at what rate will it be released? And there's a bit of pushback on the folks who study the methane and hydrates. For example, Igor Sinotov and Natalia Shakova, husband-wife team, they've been doing a lot of the work of the methane and the permafrost and the hydrates in the Arctic Ocean. And their hypothesis is that there's a methane time bomb waiting to go off. Well, they've been getting a lot of pushback, saying that they're overestimating this and so forth. But it's very difficult to sample adequately in the ocean. It's a big place. So a lot gets missed. Even using satellites, you miss a lot when the satellite's trying to measure when a methane plume happens. And people need to look at not what's the release within a human lifetime, but what's going to be the release over 1 to 2 or so millennia. And when you look at it in that terms, there's a lot of methane being released and will continue to be released. And, you know, and I, just to be open here, I work with Igor and Natalia, so I know them. I know them to be excellent scientists. They do very good work. And I remember discussions with Igor, they saying that's what keeps them up at night, is how much methane is total in the ground and at what rate will be released. Because he basically said, his words was like, it's curtains for humanity. That all gets released very quickly.
And it looks like it's already, started. That process has already
it has.
come into play. So.
It is, and again, it's just starting to probably accelerate, exponentiate, becoming more and more. And I mean, when you have the lowball estimates are 0.45 teragrams per year. Okay, a teragram is 10 to the 12th. So 10 to the 12th. So you can say 10 to the 9th kilograms, to put it in those terms. That's it. That's a lot of methane being released.
Yes. Yes, and on that note, Jim, I guess to wrap it up, the situation is not is not a pretty one, but
I just also want to give a shout out to, I'm sure you're familiar with their work, Environmental Coffee House with Sandy Shellis and Jennifer Hines.
Giving them a shout out right here. There you go.
Well, I'm figuring that's where you probably found out about me, but
yeah, that's where. Well, I saw you on Sandy's show, and then I kind of saw you on Twitter a little bit. We're kind of cross paths. There's a little bit of an ecosystem on Twitter where people, the environmentally aware, talk to the unaware. So, there's always this discussions with people who are like, what? I enjoy your work, Jim, and I'd love to have you back on. Maybe we can get the sound a little bit louder, or we do a little troubleshooting before the show. But I could hear you. I can hear you on my monitor. So I think you came through. And I think people are going to be able to watch this video after it's over, and they'll be able to hear what's going on. So,
I definitely appreciate you having me on. And definitely like to come back. And folks, check out my YouTube channel, Science Talk with Jim Massa. I talk about a lot of these things. I talk about some paleontology as well, because I have to have a little break from the climate
Oh, sure.
every so often.
Interesting subjects.
But
Yes.
I talk a lot about what's going on, the latest research. I do some deep dives where I kind of explain what we hear about salinity and overturn and mixing. So I do explanations on that, so that, and it's geared to the non-professional scientist, so that hopefully people get a better handle of those concepts.
Sure.
And they can apply it to what's going on. So I talk about North Atlantic Oscillation, Arctic Oscillation, and so it's all there. So just scroll down on the video tab.
Awesome. Yes, everybody, please check out Jim Massa's channel, Science Talk. Is that right?
Science Talk with Jim Massa.
Science Talk with Jim Massa. And thank you so much, Jim, for joining us today.
Thank you.
We'll have you back real soon, and hopefully we'll people will be able to hear you better. I could hear you. I don't know. Some people could hear you. Some people couldn't. I don't know. Well, it's always a crapshoot with these things. But
Yeah.
thanks again, Jim. I appreciate it, and I'll talk to you real soon.
Cool. Thank you.
All right. Bye. All right, guys, we are still going, and yes, we have Jamie from Rockfin. It's very hard to hear Jim. Yes, I think that was about one of the main upshots from this discussion with Jim, but all good. I could actually hear Jim, so it's just weird. I could hear him on my monitor too, so I don't know. I don't know, guys. There's some kind of weird bug in the system, and I don't know how to really work that out. But anyways, whatever. We'll have him back. And once this video is done and over and uploaded, y'all can listen again, and I'm sure you'll probably be able to hear him a little bit better. But thanks for joining me today, guys. Thank you so much for your eyes, your ears, and your conscience. I always appreciate you joining me every day for these chats. I might come back with another video today. I'm not sure. I'll let you know. I'll surprise you. Anyways, until next time, guys, peace.